Today we shall study about electric flux. Electric flux del phi through an area element del S is defined by del phi बराबर E dot delta S. बराबर E delta S cos theta is shown in the figure. It is proportional to the number of field lines cutting the area element. The angle theta is the angle between E and delta S for a closed surface. With the convention stated already, theta is the angle between E and the outward normal to the area element. We could look at the expression E delta S cos theta in two ways. E times the projection of area normal to E or E dot delta S. It means component of E along the normal to the area element times the magnitude of the area element. The unit of electric flux is Newton per coulomb meter square. Now, in SI unit, now the total flux phi बराबर summation E dot delta S or integral E dot delta S. The electric dipole. An electric dipole is a pair of equal and opposite. A pair of equal and opposite point charges Q and minus Q separated by a distance 2a. The line connecting the two charges defines a direction in a space. By convention, the direction from minus q to plus q is said to be the direction of the dipole. The midpoint of location of minus q and q is called the center of the dipole. The total charge of the electric dipole is 0. This does not mean that the field of electric dipole is 0. Since the charge q and minus q are separated by some distance, the electric fields due to them, when added, do not exactly cancel out. However, at a distance much larger than the separation of the two charges, forming a dipole R is very bigger than 2a, the fields due to q and minus q nearly cancel out. Q and minus q nearly cancel out. The electric field due to the dipole falls off at a large distance. Taken then like 1 by r square. The dependence on r of the field due to single charge q. Now the field of an electric dipole. The electric field of the pair of the charges minus q and q at any point in a space can be found out from Coulomb's law and the superposition principle. The results are sample for the following two cases: when the point is on the dipole axis and when it is in the equatorial plane of the dipole. It means on a plane perpendicular to the dipole axis through the center. The electric field at any general point P is obtained by adding the electric field C minus Q due to the charge minus Q and EQ due to the charge Q by the parallelogram law of vectors. Now, for points on the axis, first, let the point P at a distance R from the center of the dipole on the side of the charge Q as shown in figure 1, EQ बराबर Q बटा 4 pi epsilon naught R minus A का whole square in vector P. And when P in vector along the dipole axis, E plus Q बराबर EQ बटा 4 pi epsilon naught R plus A का whole square in vector P. Therefore, as shown in the figure, the total field at P बराबर E plus Q plus E minus Q बराबर Q बटा 4 pi epsilon naught 1 बटा R minus A का whole square minus 1 बटा R plus A का whole square बराबर Q बटा 4 pi epsilon naught 4AR बटा R square minus A square का whole square. For R is very very greater than A, E बराबर 4QA बटा 4 pi epsilon naught RQ in vector P. For R is very very greater than A, It is equation number 1. Now, 2 for points on the equatorial plane as shown in the figure. The magnitude of the electric fields due to the two charges plus q and minus q are given by E plus q over q bata 4 pi epsilon naught 1 over r square plus a square and E minus q over 4 q bata 4 pi epsilon naught 1 over r square plus a r square plus a square are equal. The direction of EQ and E minus q are shown in figure 2. Clearly, the components normal to the dipole axis cancel anyway. The component along the dipole axis add up. The total electric field is opposite to P. Normal unit vector P. We have E over minus E plus Q plus E minus Q cos theta barabar minus 2QA bata 4 pi epsilon naught R square plus A square to the power 3 by 2. At large distance R is greater than A, this reduces to E barabar minus 2QA bata 4 pi epsilon naught RQ. The displacement vector P of electric dipole is defined. The dipole moment, dipole moment vector P of an electric dipole is defined by P barabar Q guna 2A. In terms of P, the electric dipole field of a dipole at a large distance takes sample form. Thus, E barabar 2P bata 4 pi epsilon naught RQ at a point on the equatorial plane, E barabar minus P bata 4 pi epsilon naught RQ, where R is very greater than A. Point dipole. When the dipole size 2A approaches 0, the charge Q approaches infinity. The dipole size approaches 0, then the charge Q approaches infinity in such a way that the product P barabar 2QA is finite. It is not infinite, but dipole moment is finite. Such a dipole is referred to as a point dipole. Physical significance of dipole. In most molecules, the center of positive charges and negative charges lie at the same place. Therefore, their displacement, therefore their dipole moment is 0. CO2 and CH4 are of this type of molecules. However, they develop a dipole moment when an electric field is applied, but in some molecules, the centers of negative charges and of the positive charges do not coincide. Therefore, they have a permanent electric dipole moment. Even in the absence of an electric field, such molecules are called polar molecules. कहने का मतलब है कि जिनके पास परमानेंट डायपोल होता है, परमानेंट डायपोल मोमेंट होता है, उसे हम कहते हैं पोलर मॉलिक्यूल्स. Such molecules are called polar molecules. As example, water molecules, H2O, example of polar molecules. Dipole in uniform external field. As shown in the figure, consider a permanent dipole of dipole moment P in uniform external field E by permanent dipole moment. It has not been induced by E. Magnitude of torque QE cross 2A sin theta barabar 2QA sin theta. Its direction is normal to plane of paper. Thus, tau barabar P cross E. The torque will tend to align the dipole with the field E. When P is aligned with E, the torque is 0.